Hi, my name is Radek. I'm a senior data scientist at NVIDIA, and today let's look at the terms artificial intelligence, machine learning, deep learning, and data science, and let's see how they relate to one another and what they really mean. For each, I prepared a bit of a backstory that hopefully will be interesting to you, then that will definitely help deepen the understanding of what those terms convey. So let's start with artificial intelligence, which is a very broad term, and this field deals with emulating intelligent behavior. So first we have to ask ourselves what intelligent behavior really is. And as we'll learn in a second, the definition has evolved over time, but intelligent behavior is what humans and non-human animals do that we find quite elaborate, quite complex, something that might be different to emulate using a machine. So an example of that might be telling what's in a picture, whether it's a cat or a dog, or telling the relationship between objects in the picture, whether the book is on the table or underneath the table or behind the table, or it might be diagnosing a patient based on some data, or playing chess or playing checkers. And all of these have been attempted under the broad umbrella of artificial intelligence to lesser or greater extent. The very hot recent models like ChatGPT or Stable Diffusion that generate images or that can reply to you in a human-like manner, these are definitely examples of artificial intelligence as well. But how this field has evolved over time, for instance, in 1990s, OCR, optical character recognition, would be considered by many as part of artificial intelligence. So what OCR is when you feed a photo of an invoice or when you feed a PDF document to your computer and you ask it to go from that representation to actual text that you can edit. That was considered quite challenging, but now that it is a solved task, we no longer, most of us, would not consider this as part of the artificial intelligence field. So this just drives home how much in the eye of the beholder it all is. It's a very fluid definition. So when does this field start? And for the beginnings, we have to look very far back. Even in the 1940s, in the papers by Alan Turing, the father of modern computing, there are mentions of a computer program that would learn just like a child. And then in 1943 we have a paper by McCulloch and Pitts where they proposed the first artificial neuron. But what is generally assumed to be the founding moment of the field, it was a summer workshop at the Dartmouth University in 1956, where a lot of big names were invited and did show up. So we have Marvin Minsky, we have Claude Shannon, we have John McCarthy, among a couple of other individuals, and they all came together. They started to discuss artificial intelligence, and this is considered to be the seminal moment. And how this was important is that suddenly they started to correspond with each other, they started to cross-pollinate their thinking with ideas, and this led to many seminal works. Among other things, in this atmosphere was where a programming language that is associated with artificial intelligence was born. So official date is, I believe, 1958, that marks the birth of Lisp. However, it all happened in conjunction with all the discussions that were being had. All right, so that's it for artificial intelligence. Now let's look at machine learning. Machine learning is a subset of AI, and whereas artificial intelligence doesn't put any boundaries, any constraints on how intelligent behavior is to be produced. So, if you had a crystal ball that you constructed somehow and it would show intelligent behavior that you could demonstrate on a large sample size, this could be considered under the umbrella of artificial intelligence. But machine learning is a much narrower field, which also strikes to emulate intelligent behavior by using a very specific mechanism, and that is that of a computer program that can learn. So how this transpires is you show your computer examples of what you'd like it to learn. So it could be, for instance, the images of cats and dogs, and you show it a picture of a cat and you ask the program to make a prediction. And the program will err in its prediction by some degree, and you hope that if you apply a learning rule, the program will be able to modify itself so that in the future, when it sees a similar image, it will be able to predict better that the image in fact contained the cat. So that is all that is implied by machine learning. It is a program or a hardware implementation that can learn based on experience, based on data. We think of machine learning as something being very modern, but actually it also dates back to 1956. So in 1956, Arthur Samuelson, I believe his name was Arthur Samuelson, he demonstrated the first ever checkers program. So we consider machine learning to be a very modern term, but in fact we can trace its roots back all the way to 1956 as well, which is a year in which Arthur Samuel showed to the public the first ever checkers playing program, where it learns what to do based on playing against itself. So it plays multiple games against itself, and from that it learned how to play the game well, which, you know, if you look at some of the very recent algorithms, like the one playing StarCraft, or the one playing chess, right? Or even poker, it's still the same idea, a computer playing against each other to learn. But the roots go all the way back to 1956, and I think that Arthur Samuel popularized the term in his writing, in his communication a little bit later, over the years that followed. But the first program that was demonstrated to the public that could pull it off to a good result already took place in 1956. Alright, so let's move on to deep learning, and what deep learning is essentially the same thing as machine learning with a slight caveat. So whereas machine learning can be achieved via various algorithms, deep learning has to be achieved via an algorithm that has more than a single hidden layer, more than a single hidden representation. A good example of that are CNNs, convolutional neural networks, that learn from images, like we discussed before, the image of a cat, for instance, and if we feed it to a convolutional neural network, you can see that bottom layers that come in contact with the image, they learn simple representations, such as they might be able to detect edges, they might learn to detect blobs of colors. But as we go up the CNN stack, the representations that a CNN learns become more elaborate. So maybe in the third layer it will start learning more complex shapes like squares, rectangles, etc. And as we move up the stacks, it will start to learn things like eyes, noses, tails, and in the uppermost layers it will start pulling those concepts from lower layers together to form the representation of a dog, of a cat, and so on. And that's deep learning. Now, data science is a slightly orthogonal term. It's also not well defined, just like artificial intelligence is. And we can find the roots of data science tracing back to 1970s. So if somebody tells you that the term data science was invented after the year 2000, that is not true. So it was the first traces of it go all the way back to 1970s, but it is true that it was popularized after the year 2000 in the Silicon Valley boom, where suddenly there were all those internet scale companies that had a lot of data and the adage that data is the new oil, that was definitely correct, and it still is to a large extent, where if you had a lot of data, you could mine it, you could look for patterns, you could find ways how you could keep your users engaged with the platform for longer, have them spend more time on the platform, have them see more relevant ads, and this translates it directly to an improved bottom line of the startup. So what does data science imply? It implies doing any work that takes the scientific method and applies it to data. So it's extremely broad and there is no consensus. A lot of intelligent and well-educated folks have aired their opinion on that, but there is no clear definition, and how it serves is that it's a grab-all term. If you don't know whether you should say AI, machine learning, or then you can probably safely go for data science. And if the responsibilities of your job will be that of applying the scientific method to data, then probably putting that in the job description, data science, being a little bit more vague as to the methods that will be used, that is probably a safe bet. Alright, I hope you enjoyed this video and that you learned something interesting, something new. Please subscribe to the channel, please like the video, that will be an extreme help for me in growing this channel. Appreciate you watching this video. Thank you, see you, bye bye.